All right, how's it work? What's the deal here? Where's the water coming in? Where's it going out? And what's happening in the meantime?
All right, well, let's start at the beginning. The key thing about an RO system is the pre-treatment in front of it. So we'll talk about the importance of the quality of the water feeding the RO system. So we'll talk about the water softener, making the water soft, removing the chlorine through the carbon filter. After that, we get to the point where we're feeding the RO system right here. The first thing that we're going to do through the RO system is we're going to remove any total suspended solid still in the water. So what we'll do there is we're going to remove anything from 5 micron on up out of the water so we can feed the RO system. From there, it's really simple. We're feeding that water into a pump. We're pressurizing the water. Ideally, we'd like to maintain somewhere between 150 to 180 PSI water. We pressurize the water, send it through the membranes, and through the permeate or the reverse osmosis or the permeate process, we're removing all the mineral content of the water. The mineral content, the high TDS water, actually has the ability to get recycled back through the feed water. So we can take some of that water and process it through the RO system again. So we're trying to reduce the amount of water that we're rejecting. So when you talk about recovery rates, when you're getting around like 1 gallon of product to 0.3 or 0.6 on the reject, a lot of that has to do with the recycle valve that's positioned over here. Okay. The other thing that you're getting is that with your reject or your concentrate valve is you're really trying to determine how much of that flow you're getting on your reject side as well. So this is really trying to prevent how much of the water is going through the reject side of the membrane. This one is taking, the recycle is taking however much this valve is allowing it to recycle through the system one more time. So ideally, you want to see a minimum of 20 PSI coming into your inlet pressure.
Okay.
And normally when your pump pressure, like I said, you want to keep that somewhere between 150 to 180. Sometimes because the inlet pressure is higher, which you have no control of, your pressure is going to be a little bit higher, which is fine. Ideally, you want to keep it in the 180 range, somewhere in that. When your system first starts out, your membrane pressure is normally going to be about 10 PSI lower than what you get on your pump pressure, and that's ideal.